Percent composition also has a formula on the back of your reference table. It's going to be using those molar masses. So again, if you're not sure how to do molar mass, there's a video 9A about how to calculate a gram formula mass. So the percent composition by mass formula is on the back of your reference table. And what it basically boils down to is it is percent equals the mass of the part over the mass of the whole times 100. Please don't forget to write out that times 100. I know that you'd probably do it in your head or in your calculator, but if I'm asking for a correct numerical setup and that times 100 is not there, then I can't give you credit for it. So it's very important that that times 100 is shown, and it's not just implicit. It's got to be explicit. So the question might ask, what is the percent comp of oxygen in Al2O3. Okay, so percent composition of oxygen in Al2O3, aluminum oxide. Now, the first thing I need to do is I need to find the mass of the whole. Okay, so the mass of the whole is the gram formula mass of Al2O3. So aluminum weighs 27 and there's 2 of them, and oxygen weighs 16 and there's 3 of them. So my total molar mass is 102. So the whole thing weighs 102. Now I want to know the mass of the part. The part, okay, is just the oxygen right there. Now, do you see that there's 3 of them? Since there's 3 oxygens, I need to account for all of them. So it's going to be 3 times the mass of oxygen, which is 16 on the top, times 100. Let's not forget that times 100. 3 times 16 is 48. Now I would expect the top number to be less than the bottom number. So 48 divided by 102 times 100 gives me a molar mass of a percent composition of about 47.1%. Okay, so aluminum oxide is 47.1% oxygen by mass. A very common example of this would be a hydrated crystal, which is really 9C, but it's not getting its own video because hydrated crystals are just things that we use for other applications. So a hydrated crystal would be something like CuSO4 dot 5H2O. Okay, and usually it's going to ask you to find the percent composition of the water in the hydrated crystal. Okay, so what you would do is when you set this up, you're looking for your percent. I'm gonna write in blue, why not? And that's going to be the mass of the 5 waters over the mass of the CuSO4 dot 5H2O. Make sure whatever's on the top is also on the bottom. That's important. You can't just do 5 waters out of the copper 2 sulfate because that's not going to make any sense. The mass of 5 waters is 90. 90 is 5 times 18. And then the mass of my copper 2 sulfate is my molar mass. I do this exact one on video 9A. And when you add them all together, you get 250 times 100. There's my correct numerical setup right there. So if that's all I was asking you for, you wouldn't have to solve it. But when you do solve it, you get 36%.